Welcome to this session on DWC. Today, we are going to work on shortcut distillation column, which is available in the columns tab at the bottom. If you see, so if I click on the columns here, I find the shortcut column. Okay. The algorithm behind this is FUG method. That means Fensky, Underwood, Gilliland correlation. So, what is the system? The system what we are going to take is benzene plus toluene. And the boiling points of benzene is around 78 degrees centigrade and toluene is around 108.5 degrees centigrade. So this is our first setup. And as we see from the boiling points, benzene is the more volatile component and toluene is the less volatile component. So we name them, the naming convention is A and B. So automatically we know that benzene is the more volatile component and toluene is the less volatile component. Done. Once this is done, now presently the shortcut column is taken into the process flowsheet window and the proper naming is given here as a feed, as a distillate and as a residue. You can also change the column also. If I click the column here, you can change this, SCOL1. I say it as distillation column 2. And I press enter. Yeah, so now let us look at the feed conditions, what is specified in this. Already have started specifying it. So let me take out all these things. So let me click on the feed. Yeah. So for our purpose, or rather, number one is the, property package chosen is Raoult's law. As benzene plus toluene are of the same aromatic compounds, so we can take Raoult's law. And the flash spec is taken as temperature and pressure. The temperature is given as 25 degrees centigrade, pressure 1.01325 bar. Here, for our calculation purposes, the temperature, the molar flow is given as 1 kilomoles per hour. So if I change this 1 kilomoles per hour to suppose 10 kilomoles per hour and I press enter, so you can see how the reading is being changed. So similarly, if I make it as 100, that means if I make it 10 kilomoles per hour, approximately in the liters, it is 979 liters per hour. So you can see if I convert this into this, sorry, I think yeah. So let us not tamper these values actually here. So this is 10. So if I make 10 and I want to, I can actually get these conversions here. So I go to the settings and then what do? I go to the system of units and then yeah, in the system of units, let me choose the volumetric flow rate. Let me put it as a liters per hour because industrially this is what we follow. So you can see now how the 10 kilomoles per hour is 979.864 liters per hour. But of course, we should also be taken care the compound amounts here. What is the compound amount chosen now as it is? The compound amount is equimolar mixture. This is equimolar mixture. That means here, here the feed is equimolar composition of benzene and toluene. So this is the first step what we have done, specifying the feed input. And of course, the condition of the feed also is very important. What is the condition given? We have given the condition as temperature and pressure. By that, it will understand what to take. And you can see the vapor phase mole fraction is taken as 0 by default because at this temperature and pressure, it is already trying to estimate it. Let's go to the second part. Now, click on the distillation column. Now you can see this is feed. You can see here, this is feed, distillate, residue. This is condenser duty, revolatility available. And very important now is given, shown up the calculation parameters, or you can say the very important is calculation parameters. How does this model calculate? So this particular area, light key. So he says light key component. What is light key component? More volatile. So let me select the light key component here. Click on this benzene. What is heavy key component? Toluene. So I have to specify light key mole fraction in the bottoms. So what I'm specifying here, you should be very careful. Light key fraction in bottoms, please. That means I want the benzene at the top, not at the bottom, not at the top bottom. So I say specify here as 0.01 or 0.02. Okay, that means toluene will be 98%. Okay. So let me change the values here. So if I change the values here, light key in the bottom, it is 0.02 and press enter. Similarly, heavy key, that means now heavy key. Okay, if I say heavy key in the distillate, you should be very, focused here. Heavy key mole fraction in the distillate. Then what is heavy key here? Toluene. So we want 99% benzene. So I say toluene at the top is 0.01. By default, it is shown as 0.01 only. Leave it as it is. Now the reflux ratio, we have to specify the reflux ratio. Then it will calculate us the other required parameters. It will take these what you call the shortcut distillation column will take all these inputs and try to calculate with the algorithm called FUG method, Fensky Underwood Gilliland correlation. So please go through what is all these three tell us. Then in the coming what you call quiz session, you can also write it down. Now I change reflux ratio to 1 and I press enter and I try to calculate. Now it is solving the flow sheet. Now see, what are the results we are obtained? So you can see number one, minimum reflex ratio is given, minimum number of stages is given, actual number of stages are 17.919, optimal feed stage is given, stripping liquid, these things are from the theory. Stripping liquid, rectifying liquid, stripping vapor, vapor liquid. That means, below the feed, it is one section, above the feed, it is one section. Above the feed, it is rectifying section. Below the feed, it is stripping section. On this basis, these things are given. Very important is that here QB, that means heat load in the reboiler. Here QC, heat load in the condenser. That is what is given to us. We should understand from the thermodynamics part also, if it is giving QC, condenser duty as 84 means we have to remove that much. So here 84.6961 kilowatt is being removed from the system, so that the vapor which is generating here is condensed into liquid. Hope I am making it clear to all of you. Here at the reboiler, I have to give steam as input. This is the steam. This is the steam. Yeah, let me rub this out. So this is the steam here. That means how much QB is being given. Okay. Okay. With this session, I end this session here. There are things which you can actually work out. So let me also show you whether there is one more thing. What is very essential is that we need to know the vapor liquid equilibrium diagram also with this. So if I go to the utilities, add utility, take material streams, binary phase envelope, you say feed, you say add utility, and then you come to this place. Yeah, you come to this place. I drag this. Let me drag this here. Yeah, so this is totally out, so that it is a square box now. Yeah, so this is the utility stream. I want to create a vapor liquid equilibrium. I want to generate the data. So you should be careful enough to utilize this DWSing, flow sheet. So this is ready for us. So it is already embedded here. So compound one is benzene, compound is toluene, envelope type is TXY, VLI, and pressure, temperature are fixed. Now, if I calculate, it will give me the diagram here. So what is important to understand in this particular what you call area? At the given pressure and temperature, what is the boiling point of? Here you see X is 0 or Y is 0. That means X1, Y1 are 0. That means these are the mole fractions of the benzene. Now these are the mole fractions of the benzene, right? Yeah. And the other one is, this is the boiling saturation temperature of the toluene, saturation temperature of the benzene. That means more volatile compound. We should be careful enough in this particular area. If I increase the pressure, what can happen? If I decrease the pressure, what will happen? Those things can be understood from this diagram. Okay. We'll again come back and meet in the next session. As of now, let us remind what we have studied here. We have taken this is feed as benzene and toluene. We are utilizing shortcut distillation column. And once you see the results of the distillation column, so the light K component, heavy K component is specified, and we want in the top and the bottom what are the compositions. And as per the specifications given, we got certain, you know, in outputs, and we have to check the out distillate also. Go to the distillate and check what is the composition of the benzene, right? In the top, what is the composition of the benzene? Now you can see, you can check here what is the composition of the benzene: 0.98999 and 0.01. Wow, that is again one more beauty of this particular column. Now residue, you can again see same thing here. Toluene is 0.98. We have specified benzene to be 0.02. So toluene we have obtained at 0.9 because we have specified the benzene information. We have not specified the toluene information. It has calculated the toluene information. Okay, we will see in the next video uh, how to actually go ahead, move ahead with rigorous distillation column also.